Ah,
Yeah,
there we
how
go.
are these people? Oh, it's working now.
Yeah.
Brilliant.
Let's see.
Hello, world. Well, hello.
We seem to be.
Hello, audience.
Yes. Okay. Cool. So we're live. So last time, let me see. Last time we were working on creating a tactic for lists, and we broke that up into several parts. So one is this list empty, which just tackles theorems about empty lists. And we have lots of examples where we use this, which is basically like our test cases for the tactic. Then we also have another tactic for single lists with examples of how to use it. And this is all based on a tactic we originally built in Coq. So we're trying to like reproduce our tactic called Listerine, and now we're calling it
Ballistic.
So see, list is always in the name, very important to get your puns right. Otherwise it won't compile. With a pun checker. And yeah, so we've done the empty lists, they went well, and we've done the single lists, almost all of them. We have a few here which are interesting, and then we will continue down like more and more complicated theorems that need to be proven with this tactic. And the idea is just so that if we have something simple with lists, we can just throw the tactic at it. We can just say, there's a list, just call ballistic. Worst case, it simplifies what we have to prove, breaks it up into cases. Best case, it proves it for us. And we are starting simple by building up these little blocks of tactics that we can combine into a bigger tactic. Maybe later we do something more complicated, but in the end, I think we want to throw the kitchen sink at it. We're just starting small. Yeah. And today I have Paul with me to help me because
Yes. We got a brain between us.
yeah, cool brain.
maybe a whole brain.
Yeah, that's amazing. Like I haven't seen a whole brain in such a long time. Okay. Yeah, so let's start over here. Here we go. Oh, maybe this is even better. Did we tackle this? I think so. Let's just check. Yeah. Okay. So if two lists are concatenated and they're equal to a singleton list, then we want to split that up. I think we can come on. Oh no.
Whoa.
Almost.
Well, yeah.
Basically, if we have two lists that are appended, we know that one of them has to be empty and the other one has to be the singleton list. And we just list all the possibilities here. So we have covered this case. Well, we've covered this way. We haven't covered the other way. So we could do that. That's maybe a simple start.
Oh.
So
sorry, I've got to go for a second. I'll be back.
Okay.
I'll be right back.
Cool, no worries. So let's just start by swapping this equal sign around. And yeah, it should end up with kind of, would be nice if it ends up with the same equalities or cases over here. For that, we first need to be able to pattern match on the reverse case. I think this should do it. So if we match on that, and then it'd be nice to add this to our comments. So if we have this hypothesis, then we want to apply like symmetry in the hypotheses, or we can even preferably do this like in our theorem. So our tactic stays much simpler. List, EQ, unit. So we just swap the parameters around. We have all our implicit parameters. And we're just just let's see what do you think? No GitHub Copilot, not exactly what I wanted. I wanted this. And now I can go, let's intro all of these things and then apply symmetry here and then just see if we can reuse this. Is intro the thing? I can't remember. Oh, so close. Okay, intro.
Yeah.
Page.
Hi, sorry about that.
No worries. Everything okay?
I am back. Yeah.
Yeah. Or let's tell the whole internet whatever happened. Yes, that's okay. That was a very everything's not okay, but I'm not.
No. It's actually didn't our hot water stopped working, so
oh wow,
we got someone here fixing it, and they fixed it. So
nice. Nice. How long was it not working?
Well, just since yesterday.
Okay, cool. They came pretty quick.
Yeah.
Nice. Okay, so I'm just trying to prove the symmetry of this theorem. I thought it would be nice just to prove the theorem, and then we can just apply it instead of doing all the symmetry work inside the tactic.
Yes.
So I think the symmetry tactic is this EQ sum.
Oh,
EQ dot.
this is one we never remember this. There we go.
This one. Here we go.
Yeah.
EQ sum. So, okay, wait, where are we? Here. Okay. So this is a thing. It's even. So we can apply this tactic. Can we? No. Okay, sorry.
You can, but
I need to be at the bottom of it.
yeah.
Can only use things that have already been declared. Okay. And now we just need to
Really
apply.
sorry, I've got to go again.
Oh, cool. Just apply that, and then it's assumption. All right. So we've proven this, and since we're in 2 files, I am a little paranoid, so I just build things, and I only needed lists to build. Okay, everything else.
Right,
good.
I'm back again.
Cool.
This time I'm back for good.
Okay. I thought now the hot water is off again. And,
No.
Okay. Here's our symmetry one. We should be able to do that. And the error is that it doesn't know about it. So we just restart our server. And it should work. Just give it a second. Yeah. So yeah, it did it. Okay. So that's a good start. Something simple. Now, these are interesting. They're all rewrites of well, okay, here's in the comments. Oh, thank you for comments. Okay, so it's just trying to push this out for some reason. Okay, and this one is trying to push this forward for some reason, and this one as well. Oh, it's the same. What's different?
It's different.
Oh,
one's in the hypothesis and one's in the goal.
yes.
Is that right?
Yes. Yes. This one is a
Yeah.
hypothesis where we're trying to rewrite, and this one is a goal where we're trying to rewrite. So interesting.
Yeah, I can see how the last two are useful because it's like pushes out the first cons.
Yeah.
But the other one, not sure.
Yeah, I'm not sure.
But
One thing we
we
know.
wrote it before.
Yeah. One thing we know is we don't have this context keyword in Lean. Right? Basically, this context is going to look through the goal or the hypothesis and see if somewhere deep in the nested expressions there lives something that matches this pattern. So it does like a recursive search. And then it applies this rewrite to that search. But what is interesting is the rewrite then redoes this recursive search and sees, can I find the thing that I should be rewriting? And then it rewrites it.
Mm-hmm.
So all of this pattern matching and rewriting is basically just try rewriting this. If you don't find it, don't rewrite. Instead of going, do you find it, then rewrite and search for it again. So here we're doing a double search. It's slightly more, it feels a bit more targeted and like more precise, but I don't think it is.
But we can just do a try, essentially.
Yeah, we can
rewrite.
just do a try. And then we don't need to reproduce this feature in Lean, because technically the only time we use it is with rewrite, because the only time we can use it is when we have something that can, a tactic that can also recursively search. So yeah, so we're just gonna do a bunch of try rewrites. Now, do we have these theorems? Yes, we have. We have this one. Oh no, that's different.
PASOK.
I see.
This is with singleton.
Yeah, this is with a singleton.
So we can just
yeah.
Oh,
so we can. We need to kind of recreate this for the singleton case so that it only applies to that. Like so. And then we should just be able to say this is exactly this theorem. No, okay, almost. Apply. Yeah, okay, that does
it's
the
exact.
trick.
We'd have to give it underscores or something, but
yeah. Okay, apply does the job, but I think we need a better name. Singleton.
Singleton.
And yeah, we're happy with just going this one way.
Yeah.
So we can say here. I'm just trying to figure out. Okay, so we have our match here, which might not do anything. Then we have our for loop here. So we should just be able to go after this. Oh, yeah, like exactly this.
And does add star also rewrite in the goal as well as the hypothesis?
Right. But let's test it. Let's not take my word for it. Okay, so
Copilot's word for it.
Let's see.
Copilot was guessing.
That was close, but no. We have this, and we have. Well, what do we want to? Let's start with the hypothesis. Just. Oh, yeah. We have to go look here, right? Yeah. And then I think we're trying to prove this.
Do we need a? Don't we? We'll need an equality or something. But we have a.
Yeah. Yeah.
Um, do we have an example in the code?
Oh yeah, good idea.
You just copy paste whatever you wrote.
This is the splitting.
Yeah.
No.
Example list. Oh, there's map ASOC.
No. Good. So we should write a test for this. Okay.
Yeah.
So if this equals this, then we want to say this equals, say, A's, or, and then just goes something like this.
Mm-hmm. I don't feel like it did anything. Now let's try this just to. Yeah. So I guess the symmetry issue, isn't there? Because we've got the A's on the left-hand side of the equality.
Yeah, I think also they just restart the server because we're creating these things in these two files. Okay, I wanted to be doubly sure. Look at me just spawning these instances like that. Okay. Okay, let's see this. Yeah, this is a classic rewrite tactic. Yeah, I wrote it down correctly. Oh, interesting. Oh, okay, it did work. It did work. Didn't work before, and now it is working. There we go.
Oh, okay. But hold on, we're still on this. Oh yeah, sim.
Now, cool.
Okay. So what did you have? You had to restart the server after editing the dependent file. What was the?
I had to build and restart the server, and I don't know if I just
Okay.
need to do one or both. I still don't.
Okay. That's a bit annoying, isn't it?
Will happen. Okay, now let's see if we can also rewrite the goal. Right. So now this goes to the goal, and this goes to the assumption. Yeah. And now, yeah, it rewrites the goal. It rewrites the goal by symmetry, and yeah, cool. So yeah, this add star rewrites in both. So that's good. So the next one we wanted to rewrite was this one.
Yes, outcome
in reverse. Yeah.
Right. Yes, because we want the single cons on the outside.
Yeah.
Okay.
And yeah, it's already a singleton, so we're good. We're good. Okay. Well, we need our example, right? Anyway. Hmm. So that should go in the goal, find that it needs to be rewritten, and then rewrite it, and then RW should even solve it, I think. And then we want one more where we have an hypothesis. And here, well, I like to turn it around just in case.
Right.
Well, I guess I don't need the parens.
Do you need a colon after the hypothesis instead of the equals? Yeah, that's correct. And then after that.
Ah, yeah.
Yeah.
Well, oh, yeah.
Is that not right? Oh, we can.
There we go. Okay.
Duplicate one. Okay.
That should do something once we've done this and this and done this. And now when we get here, well, it is done. In this case, we apply equism and assumption. And yeah, thank you, Copilot.
Okay.
Cool. Okay, so we're done with this one.
Lovely.
Yeah, so we can move on to this one. Finds inequality between lists in the hypothesis with a head or tail element that can be deconstructed. Oh, I see. So if you have two lists, they're equal to each other, but they both have a cons element, a singleton at the front. And obviously the front two elements have to be equal and the list has to be equal. So it's like ready to be broken up into two separate goals. And the same with if we append a singleton at the end, right? So now this goal becomes more interesting, this tactic, because it's pushing the singleton to the end. So that
then you can use this one. Yes.
Yeah. Now this tactic can pick it up and go, hey, what's up? Both these cases is just doing it in the hypothesis because the implication is only going one way.
Yeah.
This theorem has not been proven, so it would be nice to make that a theorem rather than have this logic in the tactic. But I'm also wondering if I have this in the goal, right? Then it would also be nice to turn it into this conjunction. So I think we
write this theorem.
Yeah, I think we need to write this theorem both ways. And then apply them both ways. So, and one of them is done-ish. So let's find that and put it close to that one. Oh, damn. That is quite the involved theorem. Okay. Okay. Fine. So this will be the reverse. to say, given these, I can imply that. It's pretty interesting. Let's go with sorry for now. And then we also want this one. Sorry. Where are we? We're here. List cons. EQ.
Yeah, it's like
And then no. Thick. Like these are bad names. Oh. Okay, but we have to prove these things. And then
yeah, we already have something called list cons equal. So what's that on line 285?
Oh yes. That's
okay,
exactly.
so it looks like so,
okay, great.
and that's an if and only if, so
Oh great.
okay.
Oh.
So it wasn't a bad name because it's at least consistent
Yeah,
with what you were thinking of before.
Exactly.
So that's a good property for a name to have.
Okay, that's good. So we want to use that. And we want to use this and this for tactic. Well, okay. Tactic needs a better name. It can't be named after the theorem when it includes other theorems. Yeah, I might throw it into this single because it also deals with singleton lists.
Yes.
I might just throw it here to do add. Okay, so we don't forget, then we can go back and prove this. Okay. Yeah, intro H looks good. Now split H. Oh, I always forget this. Apply n dot intro in H. Ah. Cases H. Is that? Oh yeah. Yay! Thank you, Copilot.
Cases H. Okay, yes.
Okay, so now we can just rewrite, can we? And we're done. Okay. So this reverse of this proof is pretty simple. Wowie. Okay, good to know. Okay, so we're done. Okay, so like now we can use them. Oh, I was expecting such a long digression here, but it's nothing. And we can just restart. Okay, so we need to use these great examples. So something like that, and something like this, and something like this. Okay. Oh, basically, no, this one we don't want. We just want this in the goal and the hypotheses.
Mhm.
Okay, so we have our example, and we're saying, yeah, if we have this in the hypotheses, right? We want to be able to show, well, x equals y might be good enough as an example.
Yes.
And then we want something like this for if we have this in the goal. All right. And we know x equals y, and I guess x is equals y is it feels too simple.
This is probably true by just by
Rewrite, yeah.
reflection or reflect. Yeah.
Maybe z's, and then something like this, maybe. Just a little extra layer.
Mm-hmm.
Yeah, okay. And then here, it's sometimes hard to come up with these examples.
Yeah.
This should at least give us that. And then sorry. If we have this in the goal,
Mm-hmm.
then I think we have this problem again. So
X equals y. X is y. Yes.
I think that's the best I can do. So yeah, let's see. So now we want to go, okay.
What was it? So
we have
right.
this in the hypothesis. Then we want to apply it, right?
Yeah. Yeah.
Ballistic.
App
Yes.
inch tail.
In here. So this is hypotheses. Over here, I want to add a pattern match to something like this. So we need our dollars. And we need, yeah, show that. Thank you, GitHub Copilot. And would you just say that every time? It's not going to get annoying at all. And yeah, that's not correct. We want this. Oh, no.
Yes.
This one.
What wasn't it? Wasn't it app inch tail? Because
Oh, yeah, yeah.
it's in the tail.
Yeah, you're right. Yeah. Yeah, cool. Okay. And then We want something similar, but with this one. And the pattern will be, where is it? Yes. Ah. Yep.
Yes, yes.
Oh,
Is it in the tail?
so close. Whatever. It is close enough. And it would be nice to also split these, but I don't know. I to already turn them into the two hypotheses. Maybe we have some examples. Oh, here.
On
Yeah.
name left, conj name right. Yes.
Hmm. Yeah, I don't know if this was.
So we split to H. Yeah. Oh, the modus ponens.
Well, let's see. Let's see. So we'll do this, and the name is the same, supposed to be. And here as well. And then we want our goals as well. So this is kind of, yeah, we have this in the goal. Oh, let's copy these two and then fix them. Yeah, we don't have a name, and that's fine. And also we want this. Yeah, so we can say run our tactic, apply this, and some sorry, some formatting. Same over here. Zipped list cons EQ. Yeah, and we can see what happens. Let's see. So we added these. Oh, we can. Okay. Okay, what's the problem?
Patient type mismatch.
Hmm.
So we just need to put some underscores somewhere.
Now let's see. Like, oh yeah, okay. So these should all be implied because they're all mentioned here. So and this one as well, right? These are all implicit,
Yes.
sorry. And just for consistency. Well, okay, I guess. This is kind of consistent. Okay, let's try that. Where do we have sorry? In lists? Oh, where's the sorry? Oh, hello. You weren't complaining before. 248. Let's see. I think here's the Taily.
Oh.
Okay.
Oh, it's because have we changed the when we added the implicits? Is this
yes.
so we don't need to specify some arguments?
Yeah, which one? Yeah,
Just try deleting stuff.
cool. Okay, that's good. That's what we wanted.
It should restart. Maybe.
Okay, what's the problem now? Function expected at
List cons eq.
okay. So one of them is
list cons eq.
think.mp modus potens, and what's the other one?
Yeah.
IMP and IMF maybe, or do you remember the two
you have
if
to
and
put it
only
in.
if?
Yeah.
MP and MPR. Okay, so one of them is MP and one of them is .mpr. Let's see. Okay, maybe the other way around. Cool. Okay. Nice. Okay.
Okay.
So this is something I'm still working on, better naming. But that's out of the scope for the stream. I think it's just a bit of a pain. It did what it needed to do, and in this case, it also did what it needed to do. So, well, okay, this one is not complete, and this one neither. Yeah. So here we just go rewrite h0 h1, and then riffle. Oh, so close. Split.
How do you do that? Really?
Apply and intro. Yeah. And then riffle. Riffle. Cool. Or wait, more sophisticated riffle.
Nice.
Yay. And here it.
So that was just assumption.
Yeah, assumption, good. And this one.
You should do a rewrite.
Yeah.
Then
Probably the
do
same.
the same trick. Yeah.
Yeah. Cool. We did it. That was quicker than I thought. And yeah, we can check these. Oh, we could have copied some examples here.
It looks like similar.
This is the same.
style.
No, that's interesting. Yeah, this is like using two-ish of the tactics.
That's funny. It uses the tactic and then the list cons eq.
Oh, yeah, that's the other tactic.
Okay.
Because we had them split here. So I think we should add this example. It kind of uses both. But we've turned them into one now. So. That sounds interesting. Mm. Yeah. Oh, that's my mistake. Okay, intro H. Nothing? Hmm. Interesting. Okay. Hmm.
So which pattern are we expecting to match?
I
Or
think
is
we
it
want
one of these
this.
rewrite?
I think it's this one. Yeah, we kind of want this to happen. Push it out. Let's see. We are more forceful. In H. At H. Okay. Hmm. I guess that's fair. Okay. If we didn't find that. Okay, what did we do in Coq? No, we just did that and then Ponzi Q, which should be this. Hmm.
Why would this app ASOC Singleton? Because we don't have the same thing on the left and right hand side of the equality. In our example, do we?
Yeah. Yeah, it's slightly different, right? It's
Yeah.
I just want to see this one
Well, why
again.
would it? Yeah, because that has
Just
because you have X's and Y's on the left, but not you only have Z's on the right. So how would it be right? Okay.
well, it's supposed to find this
Yes.
and rewrite it to this. Because I'm assuming. Oh, let's just not assume.
Let's see. Does that work? Did that work? Yes. So why not? Do we have to do it backwards or something?
Okay, so that's good. That's good. And then we have this X's and that. Oh, it's supposed to see it like this over here. Well, let's see what happens. That's the goal, sorry. It's the hypothesis over here. So supposed to be able to apply that. Sorry. Have H. I don't think there is an MP. I think it's just. Yeah, so that works. So it's not pattern matching this. Okay, that's unfortunate. What about if this was these like this? And now we say intro H. Yeah, I did the first part, but not the second part. It still didn't. Well, okay, I guess maybe we
Do you
should
have to-
look at it twice.
Do we do? Yeah.
No,
Oh, it doesn't work if we do it
Mm-mm.
twice.
no, not even then. Okay, printing. Let's see. I have an example in Ltac of how to print. There we go. Let's see, ballistic. Yeah, I guess that should do. And then if we go here, I just don't know where it should print.
Debug console.
All messages. Yeah, there. Okay, let's just add a little message. Hey ho, hey. Yeah, there we go. Hey,
Okay.
H. Okay. So it did pattern match. No. Oh, interesting.
What is that?
Yeah, what is
X
that?
is plus X. That's the. Oh.
Oh, that's a different. That's this.
Okay.
Yeah, it didn't match here.
Mm.
Let's do. Okay, now let's try. What was it? Z's. No.
It's got like no parentheses.
Hmm.
So H9 has no parentheses in the.
Yeah, over here.
Ah, okay.
Oh, did it complain?
No, it didn't complain, but I couldn't remember what the pattern was.
Okay. This is in the hypothesis. Yeah. Okay, let's try something crazy. Copy and pasting it. And then this goes away, right? Nope. Oh, yeah, we don't need to print this anymore. Yeah, okay, cool. Adding more parens, not helpful.
Well, how do you re-trigger the? Does it automatically rerun the whole file when you edit it?
Yes, yes.
Okay.
It's yeah, been pretty cool so far.
It did not match 8. Could he have matched something else first?
Mm,
One of the other things.
no. No. Oh, well, we could also always do this.
Ah, right. Yes.
Oh, shit.
Yes.
H9. Oh, interesting. I don't see H9
maybe
here.
it is been matched by something else first.
Good. Good. No? Here. Okay.
So which one of these? It must be one before that one, right?
Well, I guess this one maybe.
Well, let's see.
So let's move that down here. It's not this. And we can say, okay. Damn. It's pretty irritating. Hey, well, let's comment this one out. Let's do that. No. Maybe I commented the wrong one out. Okay, this one. Okay. Let's comment these out. And this one. Okay. Yeah, we don't care. We are over here. And we want to see H9 somewhere.
I think so.
Oh, it's
Don't
even
see it.
easier than that. I don't see it, so I got to even more commenting out.
What is good? Underscore example.
Okay.
How is that?
That's with the implication, right? So it's the whole goal. It didn't find it. Okay, let's make it even simpler. And we don't have to intro at all. No H, there we go, okay.
X is plus Y is plus 5.
Let's make this a single. Okay, but that's still for this, right? Okay, so let's pretend it's already rewritten.
Yeah.
What's your problem now? Hey, it finds
Okay.
it
It finds that.
and rewrites it.
Okay.
What? Like, okay.
But we've commented the other stuff out, the other patterns out.
Sorry.
So if we've commented the other matches out. So if we put the matches back in, does it still find it, or does it get stuck somewhere?
Yeah. But like, look at this, right? this one doesn't work. You
Yeah.
see, does this we forgot to comment on this. Okay. Okay, now it does nothing. If I add this, I think it's this one. Yeah, it does the rewrite. It never sees the hypothesis that was rewritten. So it's like it wasn't updated. I don't know if this will help. I think, but I'm grasping at straws here now. Yeah. That changed it.
Okay.
But do I really have to do this with every? Like, why wouldn't? That's so weird. Okay, whatever. Let's see this function. And let's add it to our tactic library. I just wanted new tactic. Where was that? Where was that? Well, even we just say this, right?
Oh.
No. No? Yeah, there we go. Okay. Oh, okay, wait. Okay. Okay, now we should uncomment things.
Yeah.
Well, actually, not yet. And just see. Okay, so this now breaks it up, and then we should be able to say assumption, and then it works, right?
Mm-hmm.
There's one rewrite, and then cool. And now we don't want to be so specific with our pattern match. We want the general one to work.
Yes.
So we want to comment this out and this in. And then it should still work. Okay, great. So we can delete this. Uncomment this. Uncomment this. Remove this read. Right. Uncomment this. And then uncomment all of these. Yeah,
Fingers crossed.
we can keep that. Yeah, and that all works. Oh, almost.
Don't think we looked at this one. This is
I
still. Yeah.
Cool. We did it. Okay.
Okay, so what is this? Why do we have to do this? What does this do?
I think this makes sure that the context is actually updated by the things that we run.
Right.
For
So
the
before
next,
it was reusing the same context.
for reading from it. So we could see that the context was changed, right? Like it had an effect, the tactic had an effect, but where this is reading from is different from what we see, or is like cached or something. And yeah. So this is necessary to make sure that the context is properly updated for future tactics. This way, the state is affected by the tactic. Yeah. And for reading from the local context by the next tactic. Place this at the start of every tactics do notation block.
Yeah, that's the important thing. Just do this.
Yeah.
Do this and your life will be fine.
Yes. So let's give an example. Something like this. For example. I don't know what the comments here look like, but that's something.
Yep. Just hope we remember.
Yeah, we won't.
We just copy and paste the old ones, so we'll be fine.
Yeah, we'll be fine. I'm sure. Like, okay, cool. So that's pretty good. Yeah, so we can move on to this. So we're at line 300. We have 1, 2, 3, and a bunch. Go 1, 2, 3, and a bunch.
Unfold stuff. Okay.
Good. Yeah. So what's going on here? Oh, this looks familiar. Oh, we just did
What?
this.
Yeah, I was going to say.
Okay. So we have 1 and a bunch. Oh, this is the 2. 1, 2. There's a third one. Okay, no, sorry. Counted correctly, went to the wrong tactic. Okay, so basically if X is appended to the front of 2 lists, then the suffixes are the same.
Yes.
If the prefixes are the same, the suffixes are the same. And the same here. If the suffixes are the same, then the prefixes must be the same.
Mhm.
So let's start by this time copying our examples instead of making new ones. Whoop. Sorry. Cool. Okay, actually, this is not interesting. And this should just be list of alpha. Okay, so okay, yeah. This is not. Yeah, it's called just the list app tactic for append.
Yeah.
And yeah, we usually copy over our tactics. So this, as Paul just said. So
Yeah. What could go wrong? Just copy paste.
yeah, nothing. And our hypotheses. And we don't need these rewrites at the end. Okay. And let's check if we have these theorems. Oh,
Ooh.
we don't.
Disappointing.
Yes, very disappointing. Are we sure we don't have these? We definitely don't. Okay, that's fun. I think they were part of the standard library, so well, we can just prove these. We've done this before. Yeah, we still have some theorems left here to prove at the end. Well, this looks. No, it's not what we want. Okay, list app inf head.
Well, yeah, prefix. That's nice.
Sorry?
Wait. Because this is app inf. Did you want to call it the same thing? Yeah, yes.
Yeah, it's easier to search for, right? So
Yeah.
even if I don't, I kind of do. So okay, so this one we want. And then we also want this. But yeah, I try to also have a prefix here for lists.
Yeah.
Sometimes makes the autocomplete easier. Okay. I need to get some water. Maybe let's take like a 5-minute break.
Yeah. Good plan.
Cool.
G5.
See you. Yeah.
Oh,
Hey. Yeah, so yeah, we can look at this prefix theorem. And I just did some intros, and then GitHub Copilot was like, hey, do you want to try induction on X's? I think that's pretty good, since that's the thing we kind of want to eliminate on both sides. It might be the right path. And then it suggested exactly a proof for the null case, which was interesting. And now we're gonna try the second case, and no, GitHub Copilot fails. So it was close. Oh, why does it fail? Oh, interesting. Look at this. You just did sump. Oh, okay. I think you're having trouble. Stick. Pulse okay.
hello.
Hello. Okay, we're
Oh,
back.
that's it. Yeah, I forgot that Zoom can't deal with removing headphones and putting headphones back in. I'd forgotten.
So I found that this theorem is just proven by sump.
Okay, that's good.
So I think it is in the standard library somewhere. And yeah, it's fine.
Perfect.
Yeah. And then this, maybe we're lucky. Yep.
Lovely.
Also just in standard library. Okay. But we're gonna apply these more. Well, I don't know. I guess we're doing some pattern matching for no reason, but why not? Why not? Although fine. So we're not gonna do anything with our goal. We're just gonna, well, I don't know. Do we also want to do something with our goal? Then we need to prove these in the reverse.
Just looking at the standard library to see what. Sorry, why do we need them in the reverse for the?
Just for the goal.
The goal one, yeah.
I don't know. It's
And the
probably
idea
nice
is that we
to
just,
have this.
yeah, exactly. The whole thing is for convenience, right? So if the more convenient you can make
Yes.
it, the better. Doesn't matter
Yeah.
how easy it is to prove anything.
Yeah, the interesting thing in these cases is we can just call simp. So the whole tactic would just be apply simp, like just simp, run tactic simp. And but maybe it's more important that we have the examples than the pattern matches, right?
Yeah.
It's okay if we replace things with something much simpler. So in this case, we just do run tactic sump.
Yeah.
And then we just make sure that it can actually do the job, which it does. And
Great.
we're just going to add the reverse. Yeah, and we're good. Did we? Wait. I feel like we lost one.
Not complaining. Oh, I see what you
We
mean.
lost one.
Yeah, there should be 4, right?
Yeah. There we go. All right.
Still works.
We're good. And we can add little comments here. Yeah. In the goal and hypothesis, simplify at least these 2 theorems. And okay, nice. So uncons. So okay, if we have something is appended to something, then either either the first list is empty and the next list equals the whole thing, or
There exists.
the first list has a single element and yeah, is appended to the rest. Is yeah. So fun.
Yeah.
And here's a tactic for it. I don't know why this is not just applying the theorem.
To take care to name stuff. C E L E 0. But then we clear C E. Oh. I don't know.
Okay, so this is our example. Maybe this is where we should start. Mhm. Yeah, we have commas in this language. And okay.
So you just have all the
Already,
cases there.
yeah, there's already no cons here. Might be better to
Yeah.
rewrite this just to give it a chance. And then see what's happening here. Okay, it does. This is syntactic sugar for the same thing. So
Good.
did you see this? Right here.
Yeah.
So it should be fine. So we can use the commas.
Mm-hmm.
Great. Okay. We would want to use this tactic, which we don't have. And then, okay, it's going to be interesting. Okay, I don't know. Oh, let's see. It's not in the goal. It's only in the hypotheses. And we're looking for this pattern. So x's plus y's
Yep.
equals, well, or y's plus z's just,
Yeah.
is equal to x x's. Yeah.
Yes.
And in that case, we want to do something. And let's get our comment. Okay. And yeah, well, first we want to prove our theorem.
Yep.
And we want to see, yeah, can we apply it? And our theorem is here. Intro sounds like a good idea. You can also do an H. Okay, well, we can cheat by looking at what we did last time. So destruct y's, so that would be cases
That's
y's
cases,
with.
right? Yep.
Yeah.
Then
No.
if it's the nil case, then we're should be len the left.
Well, we're using, oh no.
Yeah.
But yeah, you're saying it's left. Yeah, so we want to
How do we do that? Intro L or something? Or?
think it's or. Oh yeah.
or in L.
There we go. Good. And now apply and intro. And then we go down the first case, which is raffle.
Mm-hmm.
Ah, and the next. Wow. Come on. Okay. This
So we should,
sump at H.
yeah.
And the assumption.
Yeah.
Cool. And then we want this side. So I guess that's yeah, so that has to be the right side.
Yes. We don't know how. Yeah, we don't know the Y's prime yet.
Hmm. Oh, also, let's go look at our cheat sheet.
Yeah.
So here on the right, yeah, so we say exists Y's.
Oh, okay. So we do know the Y prime then. The Y prime is just the Y's.
Yes, I think it's true,
Okay.
right? Because if you look here, the Y has to be equal to the X.
Oh, sure. Yes.
So then you get this.
Mm-hmm.
So there might be a theorem here we can apply because we don't have access to our ballistic tactics since we're in the lists file.
Yeah.
But I'm pretty sure it's something with cons. This looks about right. And so if we go,
Okay.
whoop. Hello. And H, oh, no, wait, it's have. And then we want to say MP, yeah. Yeah, and then have HR H dot right. Yeah. So there we go. We have that. And so, yeah, now we can say exists Y's.
Mm-hmm.
So I saw this. I don't know what that does. What if I say apply it with Y's? Yay. No? What would you have before this? Yeah. Yes. And we say apply exists this. No? Like this is exactly this.
But we have to give it the PYs, do we?
Yeah,
First.
but PY is. Oh.
Because before applying the first one.
Okay.
Because we're saying there exists and then the two clauses. So yeah.
Rifle, is that a thing?
Or the PYs is this no, the PYs is a list of some kind, isn't it? So we want to give it the
PYs is a property.
Oh right, sorry. Y's is equal to X plus Y prime.
Okay.
That is
What did we have here?
Because the H prime R is this, yeah. Eckruffle. Okay. That it didn't like that.
No. Well, we don't know. Like, yeah, okay, this is exactly what we wanted to use, yeah. It's like, it doesn't really tell us what it wants. You see what I mean?
Yeah, it's saying there exists a PY such that
Something that has nothing to do
something. So can we just give it something? By PYs has no.
But this doesn't work because. Okay, come on.
It's weird.
Yeah.
What did we have before the first apply existing true?
Yeah.
So saying exist Y's prime, PYs, but
Yeah.
something's gone wrong here.
Let's see when we were here, right? Okay, and also, let me do this just in case.
Yeah.
So we know this cannot be true. So we rather go for the right side of the OR.
Yeah.
Okay. We apply OR right.
What does this syntax mean? Y's prime underscore one pies. It looks like a function application, but it's not.
No. This
This
is
pies comes from.
it needed a underscore name again, and
So then we can see from line 876 what the type of pies should be.
8.
Y is equals 876.
Yeah.
So it should have this type. Y is equal x cons y's prime.
Okay, so yeah, let's.
So we know that from. I guess we don't know because that's encoded in the cases, right?
Yeah, let's do this. Maybe this
Yeah.
helps even more. Okay.
Because we don't know that y underscore y cons y. Sorry, y underscore cons y's underscore is equal to y's. We don't have that.
Yeah.
Because we've used cases. So we need that equality.
Yes.
Inside of here.
Yes.
Well, that's disappeared. So we need. I don't know.
Yeah. No. I
Something in between. We need to remember that equality. We have to use induction, but just not use the induction hypothesis. I don't know.
I see what you're saying. It's well,
we must have the same problem in Coq, right? Because we use destruct. Oh, maybe destruct is.
Yeah, I think it's different.
Yeah, we also had cases in Coq as well.
Yeah.
Oh, so it's sort of like something in between cases and induction.
Let's do induction.
Do we have that equality?
No. And no, I don't think so.
No.
Okay, but we know Yeah, we know this is true. Oh, do we? Oh yeah, we know y underscore equals x. And y is equals this. Yeah, so okay. It should all fall out from that. But we've lost it.
Hmm.
So let's see. We have let's see. If we do cases, maybe we get lucky. In lean, definitely. But that's, what is this?
It is H3. So remember,
Okay, let's try something with that syntax. So cases, wise. Okay, yeah, you have to keep the type here. That might be something.
yeah.
By cases. Can we do wise? It would also, like, if we could just see pi's type, right?
Yeah.
So pi's must be equal to, okay, yeah, let's just, when we get here, right? Then pi's equals, because we've broken up y's
Yeah.
into y and y's, it is equal to y this, okay? Oh, it is saying,
Well, I mean, equality. Yes.
Yeah. we know this, okay, at this point. Okay, and we know pi now says this equals
X-axis. Yeah.
x y's. All right. Where y's is this little tick. Okay. Now we do exists. I don't know why it's not. Oh, now we need to do this. Yeah. So this becomes this. So we need to supply this.
Mm-hmm.
And we have this. We also have this, so we could get. Okay, let's just be a slightly more human. Okay, so we have HL. This, okay. So
Oh, okay. HL. Yes. Okay. So then
we just need,
HL will give us that. So haven't we got a theorem that says if the heads are the same?
yeah. The hits are, isn't this exactly what we did? No.
We can just rewrite with HL.
Could we? Oh wow, didn't. Yeah, it did something.
Oh, but the
here.
pies is yeah. But this pies is not available.
Yeah, but it
Hmm.
might have rewritten it in here.
Yeah, we can try.
So now
We
we
can try applying exist intro refl now.
yes.
No.
Tell us.
We'll have to. We can write that.
Oh,
What?
yes. Just use refl.
Well, did we need to do the rewrites on line 896? In that case, if the
Yes.
it's completely opaque.
Yeah, that was not.
You can't see what the hell is going on.
No.
You have to guess. Oh, let's do a rewrite to rewrite this. Basically, we're rewriting a comment.
Yeah.
Okay.
But it we did it.
All right.
Very unsatisfying.
Yeah.
And I'm like, why is this unused? Like,
Yeah.
okay. Anyway, that did something. And I'm just gonna check. Okay, we have a couple sorries left in this file. Okay.
Mm-hmm.
But we have this now. So we can build. And now, yeah, we want to apply it. Oh, yes, your intro H at least. All right. This should be working. Oh, I maybe restart, sorry. What was Coq doing here? What were we doing? So we applied it, great. But then we go
We did all
ahead.
this other stuff.
Yeah, we go in and like destruct it more into left and right. That's still fine to have in the tactic. This seems like a lot. But yeah, let's see. Okay.
So inversion clear was our tactic, wasn't it? Was another one of our tactics.
No.
Oh, it's not?
No, this is a built-in. Yeah.
Okay.
We had a tactic called infs, which would
right.
do, well, basically this combo. But yeah. We tried not to use our tactics in our tactics, so they're not too dependent on each other and easier to combine. Okay, so okay, let's see. Maybe there's not too many not implicits here. Let's see. Restart. It's probably a better way to do this. Yeah, that did the thing.
Nice.
Okay, but we wanted it to do more.
More.
More. Interesting. So we wanted it to split up the branches here of the ore. I think that's the first thing it does. So let's first do it manually here. I think this would be fly or.intro at age. No. Oh yeah, it doesn't do that. Split age. It doesn't like. Yeah, it doesn't like it when the tactics make more options. Cases or intro? Okay, oh, cases H with. Yeah. Okay. So if it's this, then it's both these things. So it's kind of not interesting. And if it's this, then I
Something equals y. So it's the thing in the middle.
This. Oh
Yeah,
yeah.
so the only thing that equals y is the middle in the goal. It's the we've got something or
Okay.
x's is x and y's is y. Singleton.
Well. Yeah, so it can't be this, can't be the first one. But it can still be the last one as well. Like Y's can
Yes. Y's can be empty.
be, yeah. We can do. Think. Yeah. Yeah, we can eliminate the left case. It's one of these two. And it's kind of easiest to go. Oh, okay, wait. We also need to show that x is equals something.
Yes.
So to say,
so it must be that.
oh fuck. But we don't have
So y's
x's.
must be empty then. Y's prime, sorry.
Okay.
Because if y's prime is empty, then y's can be y and x's can be x, and x is append y's is x, y.
Yes, but we don't have anything to say x is equal
Why
to
not?
something.
But where's that gone?
Yeah,
That's in our
we lost.
hypothesis. Where has it gone? Oh,
So I said apply in. And I think that's how we lost it. So let's see what it does here. Yeah, it does apply in. It does throw it away.
okay.
So we had this, we apply in, which means
So X is then is non-empty. X is so we've excluded the Y's is X and Y because we're in the right-hand side case.
Maybe it's all here in the. Oh, look at this. If I hover over P-Y's, I wonder if we had this before. Wait a second. Did we have this in when we were here?
Just hidden.
Oh.
Okay.
So we had.
Tooltip.
Yes. What? Yeah, we were right. And then when we did the rewrite, yeah, we're correct. Yes. Okay.
We just did it in the comments.
Yeah. I'm gonna keep it there.
Yeah. I mean, if we don't.
Okay, but so in here we haven't lost our x's. Okay.
Yeah, it's hidden in there. Okay. So X is X cons Y's prime.
Yeah, so here we go. We see x's
Is
equals
X cons
y's prime.
X cons Y's prime. So Y's prime
Is empty. Well, if it's empty, then y is equals this. And if it's y, then y's is empty. So both these are true.
Yeah.
So how do we now? So I guess we go apply exists.intro
We'll give it the empty, yeah.
Oh, we don't do add. Okay. Shit. Have H. H. Can we do this? Or is it? Or
I would say it should more likely to be that one, but because its X intro should give us an exist. Yeah, what's the type of that thing?
Yeah. Okay, takes a proper something that takes a property and a value, and then yeah, it returns what? Yeah. This always breaks me.
So the property is this Y's prime append Y's is equal to the empty Y. The W. Oh no, it's not.
Maybe we've exhausted our brain power for today.
Oh yeah.
Yeah, maybe that's a good
I think
place.
there must be some other tactic. Yeah.
Okay. We tackle exists, and
yeah.
Or I'll tackle it over the 2 weeks we're away and commit it to the repo, and then next time we can finish up the tactic.
Sure.
And see if we can come up with some examples to test drive it. Yeah. Yeah. So thanks
Okay.
everyone for joining.
Goodbye, everybody.
It was fun. Yeah.
Yeah.
See you next time.